Hi everyone, today we're focused on section 7.1 and we are going to look at problem number 2. Now what we're focusing on are graphing inequalities and whether that graph should be a line or a dash and whether the solution to the inequality is above or below the line. So just to give you some background knowledge, the graph of a linear inequality is a half plane, which means there's always infinitely many solutions. A line determined by the inequality. So we would graph an inequality just like we graph a linear equation, but the line that we get divides the plane into two half planes, and the inequality symbol indicates which half plane contains all of the solutions. Now, when I say that there's two half planes, sometimes on your picture, it's not going to look like the coordinate grid is split directly in half. That's okay because technically the coordinate plane is infinite in all directions. So no matter where you put that line, you can assume that it divides the plane into two parts and that the relative size of those two parts are somewhat similar. So how we decide whether or not the graph of an inequality is going to be represented by a solid line or a dashed line is that we look at the inequality symbol itself. So if I have an inequality symbol that is less than or equal to or greater than or equal to, that inequality is going to be represented by a solid line because the line itself is part of the solution set. Basically means because it's less than or equal to, that equal to part is what occurs on the actual line itself. So the line is a solution, so we're going to draw a solid line to represent that. If I have an inequality that is less than or greater than without the equal to component, it's represented by a dashed line because the line itself is not included in the solution set. So what we're going to do is we're going to take a look at a couple examples, and I want you to complete these in your notebook. And this is actually problem number 2 now, and it says determine the type of line. So whether it's a solid line or a dashed line that you would use to graph the inequalities below. And I'm just going to give you a quick problem set A through F, and I want you to tell me, would you use a solid line or would you use a dashed line? That straightforward. So take a minute, copy down the equations. Y is greater than 9 minus x. 4x minus 5x is greater than or equal to 37. X plus 2/3 y is less than or equal to 6. X plus y is less than 4. 7x minus y equals 12 is greater than 12. And y is less than or equal to 0.65x plus 33. The other thing we need to focus on is graphing the inequality. So I want you to take a look really quickly and consider the inequality y is greater than 4x minus 6. So I'm going to set up my coordinate plane. And I'm just going to do a quick square grid that goes from -10 to +10 on the x-axis, -10 to +10 on the y-axis. And if you look at that equation, y is greater than 4x minus 6. Essentially, it is in our slope-intercept form. So I'm looking at my y-intercept of -6 and a positive slope of 4. So I'm going to go up 4 to the right 1, up 4 to the right 1, and draw my line. Now, when I look at the equation for the inequality, I have a greater than symbol. It is not greater than or equal to. So the correct notation for graphing that line would be to use a dashed line like we discussed earlier. So please make sure it says it should be a dashed line because it's greater than, not greater than or equal to. The next thing we have to determine when graphing an inequality is which half of the plane do we shade in. So the easiest way to do this is to check the point for 0, 0, because when you multiply anything by 0, it cancels out, right? It turns into a 0. So if I plug in 0, 0 into my inequality, I can rewrite it 0 is greater than 4 times 0 minus 6. And I just combine my like terms, so I get 0 is greater than negative 6. Is that true? Yes, 0 is greater than negative 6. So the side of my equation that contains the coordinate 0, 0 is the side of the inequality that is also the solution.